So it's my pleasure to introduce my friend and colleague Jin Fan today. Dr. Fan is coming from the East Coast, and he's our second Fajin speaker for the Fajin lecture series, which is mostly hosted online. The Fajin lecture series is sponsored by Federico Fajin, who's a person who has an educational foundation, is interested in aspects of consciousness. I want to introduce Jin very briefly with the understanding that he will be available later today for anybody who's interested in talking to him informally after the talk at the Brain Institute, over lunch, for the remaining of the day. Jin and I go back about 20 years. We did our postdocs together with Michael Posner at Cornell. And before that, Jin did his PhD at NYU. In the Department of Psychology there, and we met when I came to the Sackler and he came to the Sackler, and we met there at the end of 1999. Before that, Jin trained in China, in physics actually, and later sort of made his way into psychology. After we were at the Sackler Institute at Cornell, which is embedded within a psychiatry department, he made his way into the Mount Sinai School of Medicine in the Department of Psychiatry and Neuroscience, where he worked for many, many years, doing all kinds of research that initially started from attention and talking about the anterior cingulate cortex. And as you can see now, we're beginning to talk about different areas of the brain that are related to the anterior insular cortex. He will talk to you a little bit about that. And today, Jin is at Queens College, part of CUNY, part of the City University of New York. He's not just a cognitive scientist, he's also a computational person. He's a very good programmer, he's a very good technical person, he's done a lot of MRI research, he's done a lot of models, he's very collaborative. He worked with many individuals around the world, including in China, his homeland. And he's a very good friend and somebody that I've kept in touch with over many years, both because of his personality, but also because of scientific prowess. It gives me great pleasure to have him here. Please welcome Jin.
Thank you so much, Amir, for inviting me to the pretty campus of Chapman University. I'm also very glad to report my study here. I have the title called Anterior Insular Cortex Plays a Critical Role in Interoceptive Awareness. That's my title. Okay, and then the other words, implication for consciousness, is what Amir added. Okay, so it's sort of challenging for me to talk about that topic, but I will try my best. So to do it, so I would like to first to define the consciousness. There are so many definitions, but here is the definition in 1986 and 1995 by Sutherland. So the consciousness is the having of perceptions, thoughts, and feelings, and importantly, the awareness, right? It's the access awareness, is the ability to report on the contents of mental experiences, like Michael Gazzaniga recently. So in that sense, there is the problem related to consciousness called the brain-mind problem. The question is, how can a purely physical system, the brain, right, constructs, okay, the consciousness intelligence? That's the question, right? So the thought of the mind is the question. So, and also this is the focus of the cognitive neuroscience currently we are studying. So there's another question. So the question is here, is the body relate to the brain and the mind, right? We talk about the brain, physical brain, we talk about the mind, and then is the body useless, right? So Descartes said a long time ago that I shall consider myself as having no hands or eyes or flesh or blood or senses, but as having falsely believed that I had all these things. Right? So if we translate this question here, or the debate is about whether or not so the body is related to your mind. And then if we further translate it down, it's the question called the brain in a vat. Okay, the brain in a vat. Right? So if you see here, if you put the brain in the vat, right, and also with all supplies, and then the brain maybe is thinking that, okay, the brain, the brain is walking, right? So does this brain know about the outside world, right? So this is a philosophical argument. So do I know the external world? Do I know? So this is the philosophical argument. So if I know the external world, then I know that I'm not a brain in a vat. Okay, that's the prime. So I do not know that I'm not a brain in a vat. So the conclusion is that, okay, thus I don't know that the external world. Means that if you only have the brain with not other peripheral senses, right, so you really don't know the brain. No, you don't know the outside world. So this is the movie, right, in 1999, The Matrix, right, so and then Matrix, then you see here, Neo even is in virtual reality, okay, blocking the bullets, right, and then he's sweating. Okay, the director of the movie knows that, okay, the body, okay, has a reaction, okay, to the reality. But anyway, so here is the brain and the body connection, right? So we have, okay, external environment, and then we have a sensory neurons, right? So, and then we have motor neurons. Sensory neuron, you transfer information, that visual information and other information to your brain, the central nervous system, to your brain. And then you make a reaction through the motor neuron, right, to move, right? That's the external environment. So we have the other side, right, for the internal environment, right? This is related to autonomic nervous system, right? You have also the sensory neurons, and also you have motor neurons to control the internal environment, right? Your breath and your heartbeat, right? So in that sense, right, so the mind, not only pays attention to the outside world, we call the exteroception, okay, we'll define later, but also pay attention to the body, called the interoception, right? The interoception can be reflective or intrinsic, both related to the outside world or internal world, right? For today, so we will focus on the left part, okay, the internal environment and also the brain, right? So it's related to the body and the mind, and also. So for the here, before I move on, I want to define a little bit about the attention or attentional processing. So we have a different type of attention based on the focus. Okay, this is, I separate them newly. Okay, so one is called internal attention. Internal attention, you can just use your brain and the mind, right? So without, any sense, right? For example, for the internal attention, you can say you have to call it exact control of attention. Basically, it's controlling of your thoughts and possible actions, but just think about the thoughts, right? For example, when we do the color swoop task, flanker task, working memory task, right? You manipulate, okay, those mental operations or manage or coordinate the mental operations, and then inside your thoughts, okay? So you don't need to deal with outside world, right? That's called internal attention. You have also external attention. This one, the external attention, needs to involve the body. For example, you need to receive, okay, the sensory information from visual, auditory input, and also you need to receive the information or pay attention to the in your body, which is called the interoceptive attention. So it's toward the somatic and the vascular body signals, for example, the heartbeat. Okay, now let's define formally the interoception and the exteroception. Right, as we talked before, the exteroception is for the external sensory inputs. Right, for example, we have 5 senses: vision, and hearing, and taste, and touch, and smell. Right, and also, but for the interoception, okay, or here I call it, okay, the interoceptive awareness IA here. Okay, for the interoception is the perception of physical signals arising from the body. It's bodily signal, right? So it's very important to inform allostatic regulatory processes, okay, about the internal state of the body, so that you can maintain homeostasis. right? So, and also importantly, is related to our subjective feelings of emotions arising from the bodily reactions, like when I showed, the Neil's response, right? He was sweating, right? So, and also other vessels are also experiences. So in that sense, okay, interoception or interoceptive awareness, called IA, is very important for, like emotional life and other, bodily signals. So here, why is so important? Before I, talk more, I want to just touch a little bit about the clinical relevance of the interoceptive awareness. For example, the IA, the interoceptive awareness, is very important in maintaining bodily homeostasis, right? And then it has the impact on the affective and cognitive behaviors and also mental health. For example, if you have issues with interoceptive awareness, so you may find, okay, now you have, if you study, okay, the disorders like an anxiety disorder and the depression and other disorder I highlight here, so you'll find that they have potentially abnormal reaction in terms of interoceptive awareness. For example, for the anxiety disorder, maybe they have a heightened reaction of the interoceptive awareness. And then for the depression or eating disorder, they have also abnormal, right? Or maybe diminished, okay, interoceptive awareness. And then for the other substance abuse and also somatic symptoms disorders, the PTSD and OCD and the ASD, they all have those symptoms. For example, for ASD, we show that, okay, you think that maybe they have diminished, okay, reaction in their, later I introduced anterior insular cortex because they have a positive deficit related to the interoceptive awareness, right? Actually, they have a higher activation because they are not processed, right? They need to involve that brain structure again. So they have a higher activation, okay, in that structure, the anterior insular cortex. But anyway, so the main point here is that, so in all major psychiatric disorders, right, you will find the symptom related to interoceptive awareness. So what are the neural correlates of the interoceptive awareness, right? So here, the anterior insular cortex, which is the focus of today, has been implied as an important structure for encoding and representing interoceptive information, right? For example, what they have is the heartbeat detection task. So Critchley and colleagues studied this topic using the heartbeat detection task in 2004, and then here they found that, okay, here the anterior insular cortex is here. Okay, I'll further show you about the details of the structure. The activation of anterior insular cortex is correlated, okay, with your performance in terms of heartbeat detection. So why insular cortex is so important? Here, there's the theory about the involvement of insula in emotion, so which argues that the interoceptive awareness is a gateway to the feeling, right? Here, if you here receive, okay, the information from outside world, the tiger, right? I just went to San Diego Zoo, okay. Then, but you don't feel that the scareful because there are we have a glass to block them, right? And then, but okay, if in the real wild world, then it's different. Okay, when you see the tiger, then you may have, okay, the visual response. Okay, so the process from the visual information, sensory information goes to anterior cingulate cortex, and then here toward here, and then your visual response, okay, also go to the insular cortex. Okay, the integration is going to happen within insular cortex. Okay, so if you have problem or deficit in the insular cortex, you will not be able to integrate the information from an external environment and then also your body signal. Then you may have trouble. Okay, so for the anterior insular cortex, it's called once an island, now of the focus of attention. So in 2010, there's a special issue on the brain structure and the function right, to demonstrate that the anterior insular cortex is so important, but ignored by people in the past. But now it's the focus of our study. Okay, so the anterior insular cortex is here, the central part. Okay, it's an insular. Okay, and then if we separate the apical formations, okay, and then you can see that, okay, here the anterior insular cortex is here. Okay, so for the anterior insular cortex, we have also called the central sulcus. Okay, like in the the cortex. Okay, the central sulcus, and anterior to the central sulcus, we call it anterior insular cortex. Okay, posterior to the central sulcus, and you have posterior insular cortex. Okay, if we see here, okay, there are from 3 individuals. Okay, so you always see the central sulcus here, here, and here. But the structure looks, okay, pretty different. There are a lot of variations in terms of the structure of the insular cortex. But anyway, you should have anterior and the posterior insular cortex. And then if you look at the MR scan, okay, this one, focus on this one. So you can see here, this region, okay, is you have central sulcus, and then you have anterior insular cortex, and then you have posterior insular cortex. Okay. So now, if we further define the insular cortex, I show you the next slide. Okay, we can see here, this is the central sulcus here. Okay, we can see here, this is the green color one, is called the AI. It's the anterior insular cortex, or AIC, we call it AIC. The right color one is called the PI, or PIC, posterior insular cortex. And then we have another region, okay, now we don't mention that much, okay, it's called the front insular, okay, the blue region, okay. So for those subdivision of insular cortex, they have specific functions, okay, related cognition and the sensory processing. For example, so one paper in that special issue, okay, show that for the green color, okay, is for the cognitive processing. Okay, for the blue color is the front insula, okay, more inferior, okay, it's related to the emotional processing, and then you have a chemical sense, and also you have a sensory motor processing for the posterior insular cortex. Okay, so which is such an insula with such a small structure that are involved in a lot of functions. So for today, so the focus, okay, is about the anterior insular cortex. We don't separate that much, okay, before the green region and then the blue region, but we just call it the anterior insular cortex, okay. So why anterior insular cortex is so important? Why? Because here, anterior insular cortex has all the connected to the frontal cortex, and for the temporal cortex, right, and to the parietal cortex, and co-activate in all the fMRI studies with cingulate cortex or anterior cingulate cortex, right? So you can see here it's connected to everywhere. So this is why insular is so important. So we have a model to argue that the anterior insular cortex is the only sensory input region, and then so that the damage that of the insular cortex causes you trouble. But for other structures, like anterior cingulate cortex, so it's one of the output regions. So if you have a problem with there, so you may be able to compensate, the function of the anterior cingulate cortex. Then you don't show, the deficit clearly. And also for the anterior insular cortex and the anterior cingulate cortex, they have the specific neurons called vena-compound neuron, called VENS, V-E-N-S. Why that neuron is so important? That neuron is called the long spindle neuron here. Okay, it's very long, and also long means that it can transfer information rapidly. Okay, and also longer. So, and also for this kind of neurons, we have for human being, we have neurons in the anterior cingulate cortex, and we have in the frontal insular cortex, anterior insular cortex. And then we have the chimpanzee, they also have those kind of neurons, and also elephants or whales in the Sea World. Okay, so those are social animals. Okay, so I'm not saying that without those neurons they don't have social they don't social, it's not true. But for those kind of neurons, we argue that it's possibly very important for the rapid change of the social world, so that our human beings are more social. So, what's the research questions and the hypothesis related to today's topic? So we argue that it's still not clear about whether the AIC, the anterior insular cortex, is necessary for interoceptive awareness. So people, they have shown that the interoceptive awareness or interoceptive attention is related to anterior insular cortex, as Chris' paper 2004, and also people decided, the deficit insular cortex really, the interoceptive awareness, but the result, is inconsistent. So for us, we hypothesize the AIC is very important to the interoceptive awareness, so that it can mediate, like the model we showed before, an individual's homeostatic state and also internal environment. That's the integration, so that to reach the subjective awareness. Right. So we have conducted 2 studies to test the hypothesis. So actually it's 3 studies. I'll show you, one by one. So before we talk about interoceptive awareness, so I want to introduce the facets of IA, so the factors or the constructs of the interoceptive awareness. So here, based on Chris' definition, so for the interoceptive awareness, is the ability, or called the interoceptive ability, is comprised of 3 factors. The first one is the objective accuracy in detecting body signal. So whether or not you can objectively detect your body signal. That's the first one. And then second one is your subject belief, whether or not you feel like you're good at detecting your body reaction, right? And then third one is really whether or not, your objective accuracy is consistent with your subjective belief. That's the third factor. But for today, we talk more, just about the objective accuracy, So then the issue is here, there are the challenges, to the measurement of interoceptive awareness, The first is that, if you measure the interoceptiveness, right, you need to have a signal, that can be clearly detected. The most popular task is the heartbeat perception task, right? They ask you to tell, your heartbeat. Can you tell your heartbeat now? Or can you tell me, the count of a heartbeat per second? Can you tell me? So if you have this kind of, smartwatch, right, you can look at it. You say, my regular heartbeat is 60 per minute, and then, maybe if I'm excited, I have like 70 or something, right? But you really don't have a clear perception. Without, I have discussion, with Amir, a couple years ago, that you have to force you against somewhere hard, and then you ought to perceive the heartbeat. Or it's really dangerous condition, right? You run away, then you feel your heartbeat, So that's a problem. So, and also people, they argued in the literature that, the heartbeat perception task, or either the heartbeat counting or heartbeat detection, is not reliable, has no reliability, and then, has no validity, right? If you have no reliability, then you have no validity. So what are the bodily signals that can be consciously detected? Do we have an idea? Which one? Yeah. That's fine, but it's not hard to manipulate, right? You food deprive them, right? So yeah, that's a good idea. So we'll try that later. So I think the best signal is the breath, right? Your breath, in and out. If I ask you to pay attention to your breath, through your abdomen, right, movement, you can clearly detect it. So then we say, this, channel is so useful, nobody uses it, right? So we can develop a task to use it to measure the interoceptive, accuracy. So what we've developed a task called the breath detection task, right? We have the breath band here, and then we have a biopack system. We have, the screen to display the signal. I'll show you in the next slide. Basically, you have the respiratory effort, right? You breathe in and out, And then we have the breath band is for the respiratory transducer, right? To change the signal, to electronic signal. And then we send the signal to the biopack RSP and then the module, right, to record it. And then after that, okay, we have the AD converter to transfer, okay, analog signal to digital signal, and then through the USB port, and then send to the PC, and then we can manipulate the signal, okay? So what we did is here, and then we can have the visual output, okay, here, okay, visual output. So what we did is at a crazy task, right? So we changed the breath signal, we intentionally delayed, okay, a little bit or more. Okay, that means it sounds like you feel that's other people's signal. It's not your signal. They call the delayed condition, or it's synchronized with your breath, like a rate. Okay, it's your own, breath. Okay, so it's non-delayed. Then, we ask you to judge whether or not the signal is delayed or non-delayed. Right? If delayed, you can detect it, or non-delayed, you can detect it. So here is the trial. We ask you the breath detection task, BDT. You show it, okay, the curve, okay, and then you show it on the screen, okay, like what you see, in the doctor office, right, in the ER room. And then here we also have, okay, two conditions, okay, in contrast. One is called the breath detection task. Another is here. This one we only have the signal, okay, or the task to detect the breath, right? So that's like an interoceptive task. But how about exoceptive task? What should you do, right? What we did here, we show a dot, red dot. Okay, yeah, here I show you very clearly. In the real task, it's a little bit dimmed. Okay, and then randomly on the curve. Okay, then in this trial or this block, we ask you to tell us, okay, whether or not you see a dot on the curve or not. Okay, half time there's the dot, half time there's not the dot. Okay, basically we have the interoceptive task in contrast to exoceptive task, right? The dot detection is to the the visual input is exoception. So basically we have the 2x2 conditions. Okay, for the breath curve, okay, we have a non-delayed, okay, and then it's delayed. The solid line, okay, is delayed. We showed you. Okay, actually your breath curve, okay, is the dashed line. Okay, so we delay that. We can manipulate delay distance, okay, and then to make it harder or easier, okay. And then we have, okay, half trials. We have the dot appear on here. We have all half trial. We don't have the dot appear on this. So what we show you, we have all the 4 conditions, okay, for each run, but you have this task. For the the breath detection task, we ask you to judge whether or not the curve is delayed, non-delayed. And then for the dot detection task, okay, ask you say whether or not, okay, there's dot appeared, right? So simple task, right? So we have the 2 different kind of runs in order to test the interoception and the exoception. We call it interoceptive attention or exoceptive attention. So that's the task. So in contrast to the BDT, the breath detection task, the dot detection task, the DDT is for exoception. Yeah, so then we have a contrast. We use the interoception as baseline, and then we can compute the relative performance of your interoception. So now we introduce the task. So the first study, we want to use fMRI to study the involvement of the anterior insular cortex in the interoceptive awareness. Right, so we recruit 44 adults, okay, young adults, and then in the scanner, for example, they run the one run, for example, 10 minutes for the BDT, breath detection task. They have another 10 minutes to run the dot detection task, right? So in here, we calculate the accuracy and the D prime of the signal. D prime is, I will introduce later, is the signal detection theory, okay? And also we measure the relative interoceptive accuracy is the performance of interoceptive awareness, interoceptive attention minus exoceptive attention, so that we can have the baseline control. We also have 3 questions included. The first one is the body perception questionnaire. So basically we argue if you have, okay, good interoception, then maybe have a better body perception, right? And then we have a trait positive experience. Why not? Okay, interoception has the relationship with your emotion life, okay? And then we ask them to evaluate whether the task is difficult for them, okay, after the task. So this is relatively, you have the breath band in the scanner, okay? And then also we can measure other signals. You can make a response, okay? Outside the scanner, we have, outside we can record, everything, okay? The further to show that one, you see the curve on the screen, right? And then you make a judgment whether there is delayed, undelayed. for one run, or another run you judge whether or not is their start appeared or disappeared. So for MRI, I want to just briefly explain about the difference between MRI and the functional MRI. For the MRI, right, you have high resolution. Okay, you scan them for 10 minutes to get high resolution and anatomical structure. But for the fMRI, it's very slow. But you can scan the brain, the whole brain. Okay, low resolution every 2 seconds. Okay, it's the time per resolution is much higher. So for us, we use the fMRI. Okay, to detect the signal from the brain. Okay, what are the signal, or what is the signal we detect in fMRI? So it's basically called the BOLD, B-O-L-D, right? It's called the blood oxygen level dependent signal, which said when you have mental operation, in certain, or mental activity in certain brain region, you have, you need more oxygen, Then the brain overcompensate, the oxygen in that region. So here, if you have brain activity here, that region have more, oxyhemoglobin there, right? If you have those, hemoglobins there, then you have more homogeneous of that region. That region is more homogeneous, and then you have a stronger signal. I make it simple, right? So it means you have neural activity, you have more blood flow to that, and more oxyhemoglobin, and then you have more signal in that region. Okay, the problem with fMRI is that the response, is pretty slow. Okay, you reach the curve, the called hemodynamic response at about 5 seconds. So this is why for fMRI, we need to have a specific design to overcome or to deal with that kind of the slow temporal resolution issue. Okay, for fMRI, and also we have the timer series, right? Every 2 seconds, and we smooth the signal to to enhance the signal to noise ratio, and also we normalize your brain. Your brain, my brain, will have different shape. Okay, so maybe you have more round shape, you have more oval shape. Okay, but then we need to normalize them to one template so that we can average people together, and then we do the regression model called general linear model, right, to see whether or not the predicted signal, which is the blue line, is correlated to the real signal, which is the red dot, right? If they are highly correlated, we have the statistical parameter map, and then we say, this activation. The activation is not real activation. It's called, is the t value or z value is above certain threshold. I mean, it's related, significantly correlated with the task condition. So this is in the real scanner, right? For the task. So we scanned 44 adults, right? So, and then what we showed here is that, here, if we use, remember there are two kinds of tasks. One is breath detection, right, and dot detection. We use the breath detection minus, the dot detection. We showed, strong brain activation for the frontal parietal network, and also the anterior insular cortex, and also anterior cingulate cortex, So a lot of brain regions, people can argue, later I'll show you, this is the issue. Maybe they say, the task, or interoceptive task, is much difficult than the exteroceptive task. It's really the confounding of task difficulty. Then what's our solution, right? Our solution is that we argue that, for the breath detection task, we see here, if delayed versus non-delayed are different, That's related to bodily, right? Awareness. We can see here those difference. Then you can see here, right? You have AIC more clear, right? You have less region involved. The AIC is involved. Another more restricted argument is if we study the interaction, the more clear is related to interoceptive awareness. What is that? The interception is here. We can see here the activation is AIC is activated together with some regions, right? The AIC is more clear here. It's in anterior insular cortex. It's between, we will define anterior insular cortex and frontal insular cortex here. And then the interaction is that, when you have a delayed versus non-delayed condition for the interoception, you ask to judge whether or not it's your breath or delayed, right? So for delayed, you have strong or greater activation in the insular cortex, right? Compared to non-delayed here, But however, for the exoception, if you ask it to judge when there's a dot or something, right? So you don't have difference between delayed and non-delayed. You don't care about delayed, non-delayed, okay? But also you have less activation in the insular cortex. But anyway, so this is called interaction, where the difference between, delayed, non-delayed is much bigger than here, right? Here actually is no difference. So we argue that the interaction reflects, okay, the interoceptive awareness, okay, which is also, we show that in the anterior insular cortex. So we further, okay, checked it. So if, okay, we have a relative interoceptive accuracy, right? So it's here, this is the behavior performance. And then this is the behavior performance, okay? So you have, okay, better, okay, you have a greater, higher score in the body perception questionnaire, right? So you feel body more accurately, you can perceive your body better. Okay, and also, if you feel that, okay, here is less difficult, okay, if you feel this task is not difficult for you, and then you have, okay, the greater, no, let's see here. Oh, you have, okay, if you have a less difficult, okay, you have a greater, okay, if you have a more difficult, okay, see, if you feel more difficult, okay, then you have, okay, let me see here, let me see. Yeah, if you feel more difficult, okay, then you have less activation. Okay, if you have more activation, okay, then no. If you feel more difficult, okay, then you are less accurate. Mm-hmm. Right. So that's the question. Okay. So and also this one is related to your positive experience. So if you feel your body more accurately, you have more positive, more positive experience. So if we examine the correlation between the activation, okay, which is we define the interaction, okay, which I show you interaction, and the interoceptive attention performance or interoceptive awareness performance, we can show that if you have a greater, okay, interaction fact, or we just think about this activation, okay, then you have a better performance on the task. Right, so they are positively correlated. Means that, okay, this is individual difference. See here, you can see we have 44 dots, means 44 individuals, right? So if you have a better performance, okay, in the task, means you have greater activation, okay, for that, right? So for the task. And then what's the underlying mechanism for the interoceptive awareness? Then we further examined the connectivity of the interoceptive task, right? So we know that we have primary somatosensory area, okay, in the brain, the posterior central gyrus, right? And also in this task, we also have a visual cortex, right, to perceive, okay, the dots, okay, for all, the information from outside, even the curve, right? So we examine the connectivity, okay, between the insular cortex and those, brain regions, the somatosensory region, and also the visual cortex. Here, this is the region we studied. Okay, it's more related to lip or lung, like a movement. And then here, this is the seed of the insular cortex, and then this is the seed for the posterior central gyrus for the somatosensory, okay? And also we have the visual cortex. What we showed here is that if, okay, we have a greater, okay, if we have, okay, interoceptive task, okay, the connectivity between the anterior insular cortex and the somatosensory cortex is going to increase, okay? And then, however, okay, the direction is opposite. So if you pay attention to your body, and then you have a decrease, okay, if you have interoceptive, you have decrease with the connectivity between the anterior insular cortex and the visual cortex. So this is the model we call the DCM, dynamic causal modeling. We show that, okay, the interoception modulates, okay, the connectivity between the somatosensory area and the ESC, and also, there's the impact on the visual input, okay? But anyway, so here, up to here, am I convinced you that anterior insular cortex is important? Right? So, but, okay, there are still some issues in the fMRI study, right? So the why I said, okay, because you have a different breath effort, okay, related to interoception and exteroception, right? They say, oh, you have a confounding factor. So this is why for this paper, we have to further argue, okay, something, okay, not just by just examining the interaction, but we argue that the interaction, okay, is important, right? Should be the, pretty pure signal to reflect the interoceptive awareness. But, okay, that's the interaction we define here, delayed versus non-delayed, right? For the interoception minus delayed versus non-delayed for exteroception, that's where we define the interaction. This is what I showed you before. And then another solution is that we have to regress out, okay, the physiological signal, right, breath effort or something, the heart rate. Okay, that's what we are asked by the reviewers of this paper. So what we did, we have to here recruit. Okay, for the first one, we only give them feedback of the signal of breath, right? But we didn't record their heart rate. We didn't record their, breath, like a curve, okay, into the computer. What we did, we have to, okay, in order to address the reviewers' comments, we have to conduct a second fMRI study, okay, another 30 subjects, and then to regress out. Then for that study, we record the heart rate, we recorded the breath rate, and then we have this fancy, from Glover's, group, and then we have all the regressors, okay, to involved, okay, and the derivatives of the something of the regressors or the signals, and then in order to regress out the physiological signal, breath effort or heart rate change related to the task. Right? But here I show you basically this slide just show you before or after we regress out those signals, there's really no significant impact, okay, on what we found before, right? So if we examine, okay, this sample. This is another 30 subjects, right? We also show the interaction effect, right, in the anterior insular cortex, right? It's the same, okay, as the first study, and also we showed, okay, the correlation as I showed before. When they have a higher activation in the anterior insular cortex, right, they have better performance for that task, right? Yeah, so we solved the issue, right? So then we have a further issue, okay, related to this. Okay, first issue is with fMRI. Maybe Amir, criticized a lot about the fMRI study. So for fMRI study, so we can only show, okay, the involvement, which is the correlation, right, between the task and that, okay, right, and the correlation between activation and also the task or the specific cognitive component, right? It's called cognitive subtraction. But can we show, okay, whether or not, okay, the AIC or certain brain structure is critical. Critical means necessary, right? If you have a problem with that structure, whether or not you have trouble with that cognitive function, right? So it's still not clear, right? I only showed you the correlation, right? So how to solve, okay, this issue, right? So what's the study we should study, right? So here for your institute, you have TMS, right? So for me, I don't have TMS, right? So what should I do? So what we did is we had collaboration. We conducted the lesion study directly, right? So when they have the glioma, the tumor in the insular cortex or the brain regions, right? So they have to do the surgery procedure, right? Right. So then they have damage, okay, yeah, because of tumor, and then of the certain brain structure here, which is AIC. And then we can examine, okay, whether or not they have issues with the interoceptive awareness. Okay, here we recruit 6, okay, male patients, and then they have the unilateral one side, okay, of AIC, lesion, right? And also we have recruited 6 patients with the focal lesion in the regions, not in the insular cortex. Mostly they are related to the temporal pole, okay? And then we think temporal pole is less related to, okay, the cognitive function we study here. So, and then we have the normal control groups, okay, they are normal people, okay, matched age or education, right, so that we can have normal control. Why we have the second group, the BDC, the brain damage control group, people, they argue that here, if they have a brain surgery, right, maybe it's simply because of brain surgery, and then they have trouble with with the interoception or with certain brain function. So we have to rule out that possibility. This is why we have this design with 3 groups, okay? For the lesion, okay, we have the construction of the lesion. Okay, because they are unilateral, we have flip, okay, someone, okay, if they are to the right, okay, both we flipped all the lesion into the right. We have two on the left, but we flip to the right. So we can see here, okay, here is the overlap. Okay, right color means 100% overlap. Okay, means that all patients, they have lesion over there. Okay, and then if you can see here, all of them, okay, they have a lesion in the anterior insular cortex, which is perfect for us to examine whether or not they have deficit in interoceptive awareness, right? So, but we don't have that much overlap in the posterior insular cortex, okay? So let's come back to talk about the signal detection theory, the D prime and the beta value. So the D prime, okay, reflects, okay, the distance between what you have in your mind, the signal, the noise, and the signal. Okay, if you are very good to detect noise and signal, the distribution between noise and signal, they should be separated clearly. Okay, but if you are deficit, right, then they overlap, right? Or if they total overlap, you cannot separate them at all. So the bigger D prime, means you have more sensitivity. You can separate them, and the beta value means your bias. Okay, in the signal detection theory, the bias is independent of D prime. Okay, so we can, we don't need to deal with here, but we show that here, later I'll show you next slide, here they don't have problem with bias. Okay, they are like the normal, but they have problem with D prime. Here's the data. Okay, for the accuracy, that's regular computation percentage, right? We can show that, okay, this, the normal control is here, the brain damage control here. If we plot, okay, the 6 patients here, you can see clearly they have problem compared to brain damage control and normal control. They have problem in terms of accuracy related to breath detection, okay? And then if we use the signal detection theory, so we also show the same thing. They have problem. For someone here, they have zero means more random. They cannot separate them at all. Okay, that's the problem. And for the beta, the bias, they don't have, they are not abnormal in terms of bias. Okay, that's related to the breath detection. And for the dot detection, for the interoception, you can see here, we did not find any significant difference among all the 3 groups, right? So we can see that, okay, the deficit of anterior insular cortex is a specific here related to breath detection task, is specific to interoceptive awareness. Okay, I'm not arguing that it's not total for the other cognitive tasks you are not going to have problem, possibly because the dot detection is very simple. Okay, they don't show. Okay, we have another paper show that if you charge them dramatically, okay, for the cognitive task, okay, the cognitive control, they also show deficit. Okay, but here we show that here at least we have the separation. Okay, we show at least, okay, the anterior insular cortex is critical for the interoceptive awareness, right? So here, our findings demonstrated that, okay, the AIC plays a critical role in interoceptive awareness, right? So first I showed you is AIC involved in the interoceptive awareness, right? And also we showed you that it's called, is lesion of the AIC is associated with the disruption of interoceptive awareness, right? It's clear. So we show that, okay, by conducting 2 fMRI studies, 1 lesion study, we demonstrate, okay, AIC plays a critical role in the interoceptive awareness. So we have the paper published on the eLab, okay, this year. Okay, so you're welcome to read it. So we argue, and we consistent with the literature, argue that AIC is the hub, as we argued before, right, for the integration of body information and also external information, and also to change the information into the internal feelings, okay? And then you can, because of that, you can maintain the homeostasis, right? So here, the AIC, with that further explained, the AIC receives modulated, okay, interoceptive and extractive input from sensory, somatosensory, and the primary sensory cortices, right? So that you can integrate, okay, exteroception and interoception, okay, over there. And also here, the next topic is about the clinical implications and applications. So Helen Mayberg in 2009 has a model, okay, with with the MDD, the major depressive disorder, okay, with a big component here about interoception. Okay, basically, okay, the symptom, okay, of MDD is related to interoception related issue, and also the treatment, for example, DDBS, okay, is also, to enhance, okay, to change the symptom, okay, to treat the symptom, also is, is related to the interoception, right? So in that sense, it has significant potential significant application in the clinical treatment. Okay, another implication is here is the mindfulness meditation. Okay, why meditation is so important? I had a discussion with Amir 2 years ago or 3 years ago in my house, right? He argued that, okay, for the treatment, you only here for medication treatment, right? So yeah, it's out of your control. Okay, only you can control the treatment that you treat to yourself is the meditation. Am I correct? Right. So this is the people they go to work from by taking Long Island Railroad in New York City, or they come out from the work. But anyway, so they can do the meditation. Okay, then they can reduce their clinical or their symptom stress. Reduce their stress. Right. So this is what I took Amir this morning. Okay, the meditation what he does. Okay, so you can ask him about it. So here, let's talk a little bit more about the mindfulness meditation. The mindfulness, here is about you pay attention or to internal or external occurrence or experience, right? And then the mindfulness, okay, is possibly further. I may not be right. Okay, is to pay more attention to your movement or abdomen movement. So that, because I study attention, I say, okay, because you pay attention to your abdomen movement, so you don't have the energy or space to think about the other things, right? Then you reduce stress. You feel good. Okay. So another potential effect related to the meditation is related to your brain. There is a paper in 2005 showing that if you do more meditation, okay, then you have the increase in terms of the volume or the cortical thickness. The cortical thickness means the gray matter, okay? In here, exactly, in the anterior insular cortex. Yeah, that's the study, like around 14 years ago published, okay? And also there's another study, newer, and it showed, okay, if you do the meditation here, you have more, look at the red color, they're called gyrification, right? You have more folding, okay, of the insular cortex. Anterior insular cortex means you have more area, maybe more volume, okay, in that area. So it means you enhance the possible volume so that, okay, possibly you can really perform or, you feel your body better. So then, also from Wikipedia, they argue that the practice of mindfulness, okay, it can be very effective in reduction of, for example, both rumination and the worry. Yeah, for sure. When you do it, you don't have the space to think about other things. So depression symptoms, stress, anxiety, and the drug addiction, right? So and also for the treatment of depression, right? They have beside the CBT. Okay, they also have a mindfulness training, okay, on top of that to make the effect more significant, more effective, okay. So now I have transferred to the last question to connect interoceptive awareness and then consciousness, right? So we argue that, okay, the consciousness, the mind, okay, is supported by the body-brain connections, okay, with the interoceptive awareness plays a critical role, right? So we also argue, okay, by the philosophical argument, and also showed you in the clinical populations potentially, that without the body awareness, there's no self. That's a problem. Okay, you have clinical symptoms. So then we argue. So here, if the consciousness is considered as the first, the perception, thoughts, and the feelings that were defined before, and B, the awareness. Then interoceptive awareness is important because it's part of awareness, right? You can aware your outside world. You have to also be able to aware of your internal world. It's also related to James Long theory of emotion, right? We know that the theory, right? So when you see something, okay, right, the tiger, okay, you start to run, right? And then you start to feel fear, right? Fearful, okay, that's his argument. Okay, the new argument, okay, new model is called semantic marker hypothesis by Damasio. Okay, and then it is argued that, okay, the semantic information is very important in the guidance of your behavior. Means you need to feel, okay, your body, otherwise you have in trouble. Okay. So for today, so first summarize. So I raised the brain, mind-brain problem, and I emphasize, the body is useful. Okay, means there's the body-mind, problem here. And also I defined, first I reviewed the construct of interoceptive awareness, and then, tried under the context of attention. So I justified, okay, the anterior insular cortex is important in terms of the structure, the connectivity, right? And then I showed you the 3 studies to demonstrate, okay, the first one is fMRI study. The first is the 2 fMRI studies, and then I have the Lesion study to examine the necessity or of the AIC. And then also I explained or introduced the clinical implications and applications. And then I talk a little bit, okay, I have to, about the interoceptive awareness and the consciousness, the relationship between them. And then finally, I have now acknowledged the ground support, and thank you for your attention.
Thank you very much, Jin. We're going to open it for question and answer real briefly, okay, and then after we do a few interactions, we're going to be heading over for lunch, but then if you want to continue to ask questions and stuff like that, we're going to be at the Brain Institute after, and feel free to do that. I just want to point out, for those of you who didn't fully understand this, okay, this is one study that he described to you that started with 40-something people that he did MRIs on, got reviewers on it, to do another study, which he did for another 30 people that he analyzed, and then he went and did another study in order to look at, other elements that have to do with a lesion study to actually say, is this a critical element for what you're saying? So the first study was his idea, the second study, the design and everything, the second study was in response to the reviewers, and that was like another study in its own. Like another full study, fMRI study, where you have to regress out some of these things, so you have to put the belt on and then the third study to demonstrate whether this is critical, whether this node is a critical node for what you're measuring. So just think about the effort that goes into that, and he's reporting on one study here, on one paper that he published. He didn't even discuss like some of the other ones. So just so you understand the amount of work that goes into some of these things, particularly when you're young, you have a tendency to just, this is just another thing, but this is a big deal. And if you're taking brain and film, Celia and Gen and Hannah, you can see some elements of, and Jeremiah first, you can see some elements of what we're talking about. You see how it pops up like every now and then? So he gave you like a crash course in psychology and imaging and all these things all in 1 hour. So that if you didn't understand anything, that's completely fine. Questions? Any questions for Jin about his presentation? Anything else you'd like to add? Go ahead, Andy.
So it seems like to me you draw a conclusion from like a very specific study on graph detection to the effect of the AIC to the IA. So as what you said, that there are other types of detection like heart rate. So I'm thinking like maybe graph is a lot easier for people to detect, so it's kind of like a combination of IA and EA.
Yeah.
So like how do you actually show that it's IA instead of EA?
Yeah, you can be the reviewer. Okay. Yeah. So so we argued, okay, here the problem is hard to to find a match, okay, in terms of difficulty task, right, between IA and the EA, right? So what we did, we first argued is relative accuracy. Okay, we partial out the the interoception, okay, the performance, and then second we argue that okay the interaction fact, because it's purely related to delay versus non-delay, is detect the body signal, but still we still cannot rule out okay the potential contribution of interoception. So, but here, if we argue this task, we have this problem, potentially this problem you argued, and then for all tasks, currently, in the literature, they all have the same problem. So we didn't solve that problem. What we solved the problem is that here the task itself is much more reliable. We have the reliability, okay. And then if we argue about the validity, then it's a usable task. Okay, for other tasks, for example, the heart rate detection, heart rate counting task, so possibly it's hard to find, okay, the reliability. Yeah.
Other questions, comments?
Yeah.
Go ahead.
I'm just curious about how, your data fit together with the bigger picture of what I know from the past that the insula has been implicated in. Things like disgust and in some studies beauty and all of it. It seems like it's hard to pinpoint what is overall the insula about. Do you have any insight?
Yeah, so there's the gradient, by Bart Craig, okay, about the insular function. So basically, the anterior insular cortex, okay, and it's more with cognition, and the from the insular cortex is more inferior, it's more with emotion, right? But okay, for the posterior insular cortex, there are also animal studies. They simulate that structure. Okay, it is in charge of lower level function, or maybe higher level, but we should discuss. Okay, so for example, when the monkey they start to eat their favorite food, right? They stimulate that region posterior insular, they drop the food. They don't want to eat. So in that sense, there's a dissociation, okay, between anterior insular cortex and posterior insular cortex. Okay, but I'm not saying that, okay, here posterior insular cortex is more, intuitive for lower functions. It may not be true. So because posterior insular cortex can be also modulated by the anterior insular cortex for other higher level function, means a social, for example, social function. Yeah.
It's a bit of a follow-up, right? It seems that the insula, like the thalamus, is just connected to a lot of different parts of the brain, so then maybe that's why it's hard to clarify where it is, what it is exactly that it does, if it does one thing, because it would be activated in so many different types of networks of activities around it. Would that be part of the issue, right? If it's if it's connected to so many other things, there's something you can question or comment.
Yeah, so for example, people they study called the right state network, right? So when you are writing in a scanner, okay, doing nothing, right? They examine the functional connectivity. It's called functional connectivity, right? Right state connectivity. So they show that the insular cortex is a hub in that default mode or something the network. Doesn't matter with default or positive. And also, for Manning's theory is that so the insular cortex is the hub, to mediate. And one network called the task positive network. Another one is called the default mode network. Insular cortex is the switch of those or hub of those networks. So in that sense, the insular cortex is so important in multiple functions, right? But however, here, if you observe the patient with lesion of that structure, they don't show the symptom that much, So yeah, then they say, why, you have the lesion of the insular cortex, one unilateral, then you don't have problem. Then my argument is that, so maybe, the other side, another insular cortex from another hemisphere still can function. Then you can do it. But we show that, for example, empathy for pain. If they have, deficit, the deficit, is pretty subtle, if they have insular damage. But you can, with certain tasks, you can detect the problem. But, when you have a bilateral, it's very rare. Patient, we had that one patient, bilateral, lesion of the insular cortex, then you're in trouble. So your intellectual ability is reduced dramatically. You cannot work anymore. In that sense, the anterior insular cortex or insular cortex contributes to the higher level of cognition. Yeah.
So then, if you have, sorry, just to follow up. If you have unihemispheric lesion in the insula, then you probably then expect more cross-hemispheric activity, right, during insular function. Do you see that?
We don't have study examining that yet, right? So yeah, it's a very good question, right? So we can see, why not? They have the change, right, after lesion, change in terms of functional activity or functional connectivity, right? We can do it. Yeah. Yeah. Theoretically, it should have different. The patterns should be altered, right? Because of the damage of the lesion. Yeah.
Any other questions before we close? Okay, so I have one question that I wanted to ask you. So you mentioned, you went to the lesion study basically because you wanted to eliminate that area. You wanted to see what happens when that area is eliminated. Let's say that we can do that with TMS. I'm not.
You can. There's a company, okay, who have the product to really to use TMS, okay, to block the insulin.
They have a special coil?
Yeah, the special design. You can check from Israel.
Okay.
So they can really touch.
Is this BrainWise, like the BrainWise company?
I don't know,
yeah,
but
I think I know them. So let's say that we were able to do that with TMS. Let's say, and we were able to do it cleanly. So we were able to go and zap, the AIC. Would you expect to see the same results that you saw from your lesion patients?
That's my prediction, right? If I make the prediction,
you don't think that the lesion patients over time learn how to compensate a little bit? So if somebody is suddenly presented with a defunct AIC, their responses are going to be quite different from somebody who learns how to live with the...
Yeah, but my argument is, all the brain structures, they are useful, right? You have a problem with a certain brain structure, okay, you compensate the function of that, but you may not be that efficient. So this is why we have the task to measure cognitive control capacity, right? We challenge them, okay? So if you use regular, for example, flying task, you may not be able to find the effect. But if we use a very difficult task or sensitive task, right, we can find the deficit. So in that sense, my prediction is that still they should show the issue, okay, the problem with certain like a sensitive tasks.
Great, thank you so much. Okay.